Welcome 9th standard students, right? So we are starting with 9th standard lessons, mathematics lessons, from today onwards, from this video onwards, okay? I'm going to give you an introduction on the first chapter of 9th standard mathematics called the number systems, right? See, when a new book is published, right, probably, the moment you start your school after your summer, vacation, in case if NCERT is coming out with a new edition of the 9th standard book, you definitely will have number system, okay? But it may be chapter 3 in the new edition, all right? So that will be the only difference. But whatever is the topic that we are talking about, we cannot skip these topics, because if we skip, we will not understand certain lessons in 10th standard, we will not understand certain things in 11th, there will be a cascading impact, right? So NCERT cannot afford to exclude these topics. Number systems will be there. The only difference is, instead of chapter 1, in the edition that I am referring, in your edition it could be chapter 3. So just refer to the particular chapter in your index, right? So we are starting off with the number systems. Let me give you an introduction to number systems. These are things that you learned in your 8th standard classes, right? See, you learned about rational numbers, right, in your 8th standard. Okay, if you don't remember, for the benefit of your understanding, I have already uploaded rational numbers videos, in the same channel. You go and listen to those videos, all right? You will get a clear understanding about rational numbers and various properties of rational numbers, right? Because without that understanding, if you jump into this chapter, you will have difficulties. Like I said, the foundation will be weak. The building can never be strong, all right? So don't mistake me. It is only for your benefit. If you don't remember rational numbers, go brush up and then come back into this video, right, on number systems, right? So let me do a recap on whatever we have studied, right? So you know what is a number line, isn't it? See, a number line is a straight line where numbers are represented. That is a number line, okay? Numbers are plotted in a number line. So let us assume you have a number line, right? You have 1, 2, 3, etc., right? As you walk through the number line and you keep picking up different numbers, how many numbers can you pick up? Your first stop would be 1, you pick up 1, right? Your next stop is 2, you pick up 2. The next stop is 3. Likewise, you keep on picking up the numbers. You can actually pick up infinite numbers, right? Because that keeps going. It doesn't end in 100, it doesn't end in 1000, it doesn't end in millions, it doesn't end in billions, right? It keeps growing, isn't it? So the numbers 1, 2, 3, etc., right? The numbers starting from 1 upwards, right? So 1, 2, 3, etc., 1, 2, 3, 4, 5, 6, etc., they are called as natural numbers. This is something that we have learnt in our previous class itself, in our previous standard, right? In our 8th standard, we have already learnt about natural numbers. So the numbers, the collection of numbers starting from 1, 2, 3, etc., these are called natural numbers. These are represented by capital N. So whenever you come across a capital N, it represents natural numbers. The moment you add a 0 to it, when the collection of numbers become 0, 1, 2, 3, 4, etc., then that collection, what do we call that collection as? Many of you would have got the answer right. These are called whole numbers, right? So the collection of numbers 0, 1, 2, 3, etc., they are called whole numbers. I said natural numbers are represented by capital N. So how do we represent whole numbers? Right? Probably you would have guessed it right. The whole numbers are represented as or with the letter capital W. Right? Capital W represents whole numbers. right? So natural numbers are 1, 2, 3, etc. up to infinity. Whole numbers are 0, 1, 2, 3, etc. up to infinity, right? Now we add to the whole numbers negative integers, -1, -2, -3, etc. Right? So you have -1, -2, -3, -4, -5 up to infinity, minus infinity, 0, and then 1, 2, 3, etc. up to infinity. Right? Imagine this number line, right, where you have negative integers, 0, and positive integers. What do you call this collection of numbers as? I already gave the answer, right? These are called integers, right? How are they represented? As you might have thought it is capital I, right? That terminology was in use many years before, capital I, right? It was being used to represent integers, collection of integers. But now we have a new terminology called Z, right? Because in German language, Zablon, the word Zablon means to count, right? So it is basically drawn from that. So the collection of integers, which includes -1, -2, -3, 0, 1, 2, 3, etc. they are represented with the symbol Z. Okay. Now you add fractions to it. You add numbers of the form P by Q, where P and Q are integers and Q not equal to 0. Right? What do you call that collection as? This is called rational numbers. Okay. The collection is called rational numbers. Right? From where do you get rational numbers, that name? Because these are fractions, right? 5 divided by 4 is a fraction. This is derived from the word ratio, right? Rational number is derived from the word ratio, because usually ratios are represented as a fraction, isn't it? So rational numbers, that is help to present a ratio, right? So that is why such numbers, the numbers that are useful in presenting a ratio, hence they are called as rational numbers. Right? And rational numbers, when you divide, you will have a quotient. Hence, the symbol for rational number collection is capital Q. See, you might wonder why these symbols are important. You know about natural numbers, you know about integers, whole numbers, etc. Why am I talking about the symbols? See, when you go to higher classes, they will not say, okay, you have a natural number collection. They will simply say, a collection of numbers represented by n, right? Or a natural numbers. Initially, they might say, n represents a set of natural numbers, right? And they will say, okay, there is an element in n, right? Prove that this satisfies this particular function, right? This is how the questions will be, okay? So these representations are very, very important for you to be able to understand the questions or lessons as you go to the higher classes. Here, in the 9th standard, these terminologies are introduced. Okay, so n represents, capital N represents collection of natural numbers, capital W represents collection of whole numbers, Z, capital Z represents collection of integers, right? And capital Q represent collection of rational numbers. And you know that between any two numbers there are infinite rational numbers. All right, there are infinite rational numbers that you had seen in your 8th standard. So if you have doubts, please go back to your 8th standard rational numbers lessons, right? For your benefit, it is already uploaded. Go and watch them. You will understand. Okay. Now, let us look at some of the properties. Natural numbers, right? You would have heard about this property called closure property. So, natural numbers are closed under addition. Natural numbers are closed under multiplication. Natural numbers are not closed under subtraction. Natural numbers are not closed under division. Now, I will not explain you why it is not closed. If you have to understand better the closure property, go to your 8th standard. I have already uploaded videos. Please watch them. Right? When you talk about whole numbers are also closed under addition. Whole numbers are also closed under multiplication. They are not closed under subtraction. They are not closed under division. The collection of integers, right, represented with capital Z, they are closed under addition. They are closed under multiplication. They are closed under subtraction. They are not closed under division. You go to rational numbers. They are closed under addition. They are closed under multiplication. They are closed under subtraction. They are not closed under division. Okay. Now, why it is not closed under division is for you to find out. Going back to my videos. What is closure property? It is for you to find out. Right? But I have given you the answer in the rational numbers videos. So it is you who have to listen to those videos and then come back and understand this lesson, very well. All right. So once you complete this video, you are ready to go to exercise 1.1. It's a very simple exercise, but you are ready to go to exercise 1.1. In case some of you, or if you do not have books, NCERT books, you can always download it from NCERT site. Right? Just take a printout of the first chapter and start, coming along with me in your learnings. All right? Right? I am there, to basically guide you. I am there to give you all forms of support. Right? But start learning with me. In case if you 9th standard guys have any doubt, right, you have to write an email to askmentorguru@gmail.com. Ask is ASK. Mentor is MENTOR. Guru, GURU. Mentor Guru. Okay. askmentorguru@gmail.com. Please write an email. Alright. Please write an email. The response to emails are free. But if you want to understand about a particular lesson in detail in person, where I have to spend my time with you, that we charge. Okay. And key to exercises we charge. In case if you want test papers, we charge. Okay. We do not charge a very high amount, but we charge. Right. That you have to remember. Alright. So please go through this lesson. Please take a printout of the book. Study along with me. We are in for some interesting times. Right. This is a vacation time which we have to utilize, properly for cementing our fundamentals. Alright. You will definitely end up, if you work along with me, you will definitely end up with good marks in mathematics. That much I can guarantee you. Alright? Okay. So let's wait for our next video. I will talk about irrational numbers, right, and some of the properties of irrational numbers. Very, very interesting topics. Alright? Great. Until then, see you. Bye-bye.